So the board is now sitting inside the chassis now. It's not, it's just floating around in here. You're going to want to hook up your meter leads up to a current limited supply. And on these Alpine amps, always hook up the cables to the potentiometers, because you can cause some circuits to go off into saturation, causing you to short some more components out. So never forget to keep your cables plugged in to your potentiometers when you're testing. So right now we're at the state where we want to power this up and check for our power supply voltage. And we do not have any of the channel FETs in. Those are removed. We're just trying to make sure that this part works, the power supply. So what we're looking for, let's go to the schematic here, and we're looking at around 78 volts plus or minus 1 volt. That is the spec for this. And we adjust VR601. So this is VR601 right here. And if we turn this on and we get power, that's great. We've fixed the power supply. At this point, if your power supply powers up, you get voltage. You should breathe a sigh of relief, because that is half the battle right there. So now we're just going to hook up to the points that are going to be producing the 78 volts. And this is specified in the service manual where those points are. And yeah, so we're gonna, if this does power up, we're going to adjust that pot to 78 volts. And once once we get the rest of everything working, we'll readjust that if needed. But if it's high, like around 90, 95 volts, we're gonna want to get that down. We don't want to stress this power supply out. So let's power it up. Plugging it in now. Let's see. Okay, well, I'll tell you one thing. She's drawing an amp right now. The fan's not spinning like it should be, but we're drawing an amp and we're getting 80 volts out. So we're getting our power supply voltage. So she is turning on, but we still have something wrong in the fan driver circuit or the fan itself. So we're just going to tweak that voltage down to 79 like it specifies in the manual. It does say plus or minus 1 volt, so we can actually technically leave it here. But I want to see if I have control. Well, 78 volts, not 79, so yeah, it was maybe a little out. So we'll leave it right there for now until we get the FETs in and go from there. I think I'm going to try and troubleshoot the fan circuit first and see if I can find out what's going on with that. I'm going to pull the leads out of the fan and see if we get any voltage on the pins that's supposed to drive the fan. So what I'm going to do is try the fan without the, I'm going to measure the fan terminals without plugging in the fan to the socket itself, and see what we get for voltage at those pins. Let's turn this on. That might tell us something. Okay, it does. Let's go up to the meter here. And we get 13.8 volts. So one would assume that the fan should run if we get 13.8 volts. So let's plug that fan back in, and we know it's not running. Now let's remeasure the voltage at those pins and see if it's still at 13 volts. Okay. We're at 1.5 volts. So now we have isolated the issue down to two possible things. One, we have a short on this fan, which is easy enough. We could pull the connector off and see what kind of impedance we have on this, what kind of resistance we may have on this coil. Or we have something going on in the fan driver circuit that's not causing, that is dragging down. We may have like a problem with the fan driver itself. So I'm going to pull up the fan connector and put this on ohms and probe these pins and see what we get. I get roughly around 13 megohms or so. So that is not going to cause your power supply, I mean your fan not to spin, or short down that voltage on that power supply. Something is wrong in the driver circuit itself. Most likely it's going to be something to do with this right here. So let's put this on diode check, and let's try and measure the junctions on this and see if we get any kind of indication that we might have a problem. There's the fan driver right here. So I'm going to try and get this in 2 shots. All right. We got a junction there. And we got a junction there. So it appears that we have 2 junctions on this component. So let's go to the schematic and see what we're dealing with. Alright, so here is the fan driver transistor right here, and it is one side of the fan is connected directly to the ground of the amplifier, and here's the ground coming in. So now we know that the emitter is connected to this point of the ground, the positive side of the fan, and it comes out the negative to the power supply. So we know we're supposed to see a positive signal here that drives the fan, and a positive signal here that's going to be the supply voltage. Now it's going to be one of 2 things. Either we don't have supply voltage here, we don't have the right base voltage here at this point here, or this component has failed. So let's try and isolate what the problem is. We're going to test the collector, emitter, collector, base, and emitter, and see what kind of voltages we get. Let's go back. So I'm going to plug the amplifier back in once again. I'm going to hook up the negative lead to the supply negative, and I'm going to check the base. And it will help if I put this on the right thing. Put this in the base. All right, we're getting 8 volts on that base. That might be a little too high to turn that transistor on. So, but it's probably limited by that resistor. So that should be okay. Let's check the collector. This is the supply. Okay, we have 13 volts, 13.8. Let's check the emitter, which goes to the fan. 1.8 volts. So we know right there that this point should be connected to that point at this point if that transistor is indeed good and turned on. So I am going to take a chance and short those 2 pins out between emitter and collector, and see if this fan spins. And we saw something funky happening there. I think the best bet is to try and pull that transistor and see if we're dealing with a bad part. Even though it's in circuit, it can still be reading across other components somewhere else. So I pulled that transistor out, and here's what I saw on the component. It has a nice little burn hole on it right around the base to collector. So that's probably why we were getting some odd sparking going on. And I don't always, recommend doing that unless you really know what you're doing. in this odd case, we're going to have some weird resistance going over there, and it was causing some kind of current across my pliers there. So yeah, that part is definitely no good. This is a 2690. This is just a standard NPN audio transistor, and I have a whole bag of these right here. And you're probably saying, of course you do. So we're just going to take a new 2690A, throw some thermal grease on it, and jam that bad boy back on there. And we'll solder it back up and see if that fan comes back on, because we really want that fan working, because that's the whole point of keeping this thing cool. You just need a little dab. Nothing. You don't need to pile this crap on there. These parts aren't that big. Put the screw in. Make sure you put it in the right direction. Make sure the text is always facing out. If you put it in backwards, you're going to be troubleshooting again for a while until you figure that out. Let's solder that back up. Alright, so we're just going to put a little flux on here and throw some solder on those leads. That looks good. I will clean that. I'll clean this whole board after I've done troubleshooting. There's no point of keep cleaning spots right after you do them, because you may have to pull that part out again for some reason. So let's give it a test. Okay, so now that we've put that new transistor in and soldered those connections, let's see if that worked. So we're gonna hook up the positive back up here and hook up my power supply. Hey, there we go. All right, so this thing is definitely starting to show signs of life now. We have the power supply working, we have the fan driver working again. So we're getting there, and the fan's pretty quiet still. Sounds good. It's pushing some good air. I mean, these things were never known to be the quietest fans, but they're usually stuffed in your trunk, so they're not too bad. All right, so now I think we move on to the amplifier section. Make sure we have our voltages at our pads for our FETs and our 15-volt supply for the low voltage stuff like the op amps and gain amps and preamps and EQ. And once that's satisfied, I feel confident throwing in some new FETs in here, and we should start seeing some signals on the scope. So now I'm going to look for the plus and minus rails for our FETs and the plus and minus 15 volts for our low voltage stuff for our op amps, EQ stuff, and a bunch of various other components that are in the low voltage circuit. What I'm going to test them on the pad. I'm going to test the pads after, but I want to make sure the regulator section is working in the power supply. So we're going to go to the schematic here, and I'll show you how you can trace this down. In the schematic, this is the output from the regulator, switching, control, and PWM. These are our power supply FETs that we just replaced. These are the two double diode, dual diode packs that come out from our transformer and get rectified into our plus and minus, I think it's 38 volt to 39 volt rails. And once they come through here, we got this point here and it looks like this point here. So these two wires go up and one comes out here and it dumps out into the collector of 613, and the other one comes up and gets dumped onto the collector of 612. So we're going to measure our collector at 612 and 613, and we should have our real voltages for the amplifier section present here. And we're also going to be checking, since this is the 15 volt regulator circuit, we on the emitters we should get plus and minus 15 volts. And this is all reference to the second ground. This is going to trick you between the power supply ground and second ground. Second ground is mostly in the amplifier section, and everything is referenced off the second ground. Power supply ground is for the power supply stuff, but once you hook your RCAs up, everything becomes the same potential, but that's how your amp knows how to light up that light that says I think it's missing or floating RCAs, and it starts flashing red, I believe. But the second ground should be referenced to anything from the 15 volt supply forward. So once we're in the amp section, we always going to be referencing second ground, and you can get second ground off of your speaker outputs. One of those is going to be second ground, and to figure out how to determine which terminal is second grounded, you can actually take a multimeter and go from each terminal channel to another channel and measure in ohms and see if you have a connection between them. And the ones that you have connection between them are most likely going to be your second ground, and the other one is going to be your output. So let's go to the, I hope that made sense. I think I've tried to explain it the best I could. It's not really super complex. These things, once you're in them a few times and look through the prints, you start to understand this stuff. Alright, so now we're on the two transistors that we said, 612 and 613, and we're going to hook up our negative to our second ground, which I'm actually just putting on my speaker output on, and it's not necessarily the negative on the output of the speaker. Don't be fooled by that. So find out where your second ground is. So I have my meter on second ground, and if you look up above here, you're going to see the voltages we're talking about. I am now going to probe the collector, which we should have our plus and minus 39 volts. Okay, so good. We have our plus 39 volts. We have our minus 39 volts. So that is a very good sign. That is going to tell us that our FETs are going to be supplied the correct voltage, and the voltage is present. Now let's make sure plus and minus 15 volts are present as well, because without that we won't have any signals to process or any other EQ stuff working. Okay, we have plus 15 volts on this emitter, and we have minus 15 volts on this emitter. So we are good there. This is good news for the rest of the amp. We now have confirmed our voltages, so we can clean up the amp section pads and fit them for new FETs. Now that doesn't mean that we don't have other issues in the amplifier section. We still could have some open Noble dual resistors here, the dual 0.1 ohm. I think they're 0.1 ohm resistors here. Some of these could be open. We could have some gate resistors that are open and all that. So we're gonna have to check all that too before we start putting FETs in. And what I like to do at this point is flip the board over and probe the pads and make sure we're getting our voltages where our FETs are going to be fitted, so we know that there is no break in the connections at all, and once we put the FETs down we should have success. So I'm going to flip this board over and we'll go from there. So we're now going to look for a plus and minus volt 39 volt rails on the amplifier section. So we're going to go to the pad of the components where the components would be fitted, and we're going to be measuring the drain pads. 1, 2, 3, 4. These drain pads are two components are going to share the same rail, plus 39 volts or minus 39 volts. So we're going to check this this drain pad and this drain pad, this drain pad and this drain pad. These two should have the same voltage, and these two should have the same voltage, which is going to be plus and minus 39 volts. So let's go to the other camera and let's see if we can verify that we have that. So remember that when the board is upside down, you now have to do things backwards. So the far right is the gate, the center is the drain. And 90% of the time, the center is going to be the drain on the FETs. So let's check here. Let's put the other camera up as well so we can see our multimeter. So the two that are on one side from this component in the middle, it usually divides off your plus and minus FETs, your IRF 9540s and your IRF 540s. So we're going to measure this pin right here. We have 39 volts. And we're going to measure on this one, and we have 39 volts. And if we go over to the opposite, we should expect to see minus 39 volts on the drain pads, and we do. Yep, so we are looking really good there. So now I just have to do that to the same thing on the other side. And what I'm going to do after that is I'm going to get my oscilloscope and hook up my signal generator, and we're going to probe the gate pads so we can see if we're actually getting a signal at the gate pads and we don't have any damage, because sometimes when you have damage from the gate or the drain, from the drain to the source to the gate through the component, you can have some damage that came back and is now compromised, and you're not getting a signal. You're not going to get a signal that's going to be firing your MOSFET to produce your audio. So we're going to make sure that we don't have any damage in the gate circuit. So I have the generator now hooked up to the amplifier here, and I'm going to be putting in about 500 millivolts. We're going to be testing these gate pads. We don't want to do this for too long because these tend to clip the pre-drive section and run them into clipping because there's no real load on them anymore because the FETs are removed, so they'll tend to look like square waves. So I'm going to be plugging in my in the amplifier here, and we'll take a look. All right, let's bump that signal up a little bit. Okay, that one's good. That one's good. That one's good. That part's good. Well, I mean, that channel's good. That kind of looks a little odd. Well, there's some parts desoldered here, so that could be part of the issue. But I don't know. We have a little bit of an odd signal on there. A little bit of, I mean, not signal, but a little bit of odd kind of ringing going on. But I'm not going to worry about that now, because it does appear we have some signals to work with. we could have a capacitor or something, or some kind of other component that might be doing this. So we're going to have to troubleshoot that if that becomes an issue. And like I said, I still have some kind of components that might be unsoldered here from the amplifier FET section when we took those out, but they don't appear to be unsoldered enough where they're not connected. So that ringing on that signal kind of concerns me on this channel. Not exactly sure what that is. So we will see what happens when we put in a couple of FETs and see if that ringing gets reproduced. My guess is it's probably going to, but we don't know that yet. So I'm going to be putting in, I'm going to start with this troubled channel first. I'm going to put in 2 FETs, 1 N FET and 1 P FET in that channel. These FETs, this channel usually takes 2 N FETs and 2 P FETs. We're going to only be putting 1 N FET and 1 P FET in here. That we'll try and see how it handles that first. So now that I have the 2 components fitted in here, I want to make sure when I power this up, I quickly bias this thing almost off, because if with 2 components in here, it's going to be a different bias than having all 4 components, and you can potentially be heating up your components very quick. So, and plus we don't know where or if anybody's been in here with the golden screwdriver. So I'm not exactly sure which direction is which. So I have hooked up the power supply in, I've hooked up my amp meter, my multimeter in amp mode in series with this amplifier. And we're going to turn it on, and we should see, you know, how many amps this thing's drawing with those 2 FETs in. And we should be able to back it down to a minimum where we can't turn it down anymore, and then slightly turn it the other way, and you'll start seeing draw a little current. And that should be almost the correct bias for those couple of components in there. So let's get the screwdriver ready, and we'll turn it on. Okay, we are at 1.9, so I'm going to back it down, going the right way. Yes, okay. So, okay, we're at 0.826 amps, and on this particular amplifier, clockwise is turning the bias down, and I'm just going to slightly turn it up until I see it move. Right about there, and that means it is pretty close to being biased for those components. So now we should be able to flip this board over and test it without these hopefully not running away on us too badly.